Hello everybody, welcome to Data Channel second interview. I'm very happy to have Mr. Hamid Fard joining me from Malaysia. He's a MVP MCM, and as far as I know, he's the only MVP MCM in this region in Southeast Asia. I'm very fortunate to have him as my second person for the Data Channel. Extremely happy to have him. We will be discussing capacity planning on SQL Server's memory usage. So how are you, Hamid?
I'm fine. Hi, Nagaraj. How's everything?
Everything is good. Thanks a lot. Thanks a lot for sparing your
You're welcome.
valuable time for Data Channel.
You're
Well,
most welcome.
so, shall we get started?
Yeah, sure.
Okay, thanks a lot again. So as you know, we are going to discuss memory capacity planning on memory usage or SQL Server's memory utilization. So, for beginners to get started, what is capacity planning? What does one needs to know about it?
Usually for the SQL Server DBAs, they need to come out with the sufficient memory. Okay, for example, you just want to set up a server for the database itself, and you don't know how much memory that the database, the SQL Server will use up. I have seen some of the servers which is in the production server, 64 GB or 32 GB. Then after we come out and we do some checkup, then we see that the physical memory is not enough, it's not sufficient. So it will reduce the performance of the SQL Server instance and the databases. We need to have some planning, which during this planning we need to calculate how much memory SQL Server instance needs. Then we can assign the what I call the maximum memory in the SQL Server instance configuration.
Interesting.
And yeah.
Interesting. How does actually SQL Server use the memory? In some of these people keep claiming, beginners or server administrators actually keep claiming that SQL Server is using all the memory or in a machine. So what is your advice for people? How does SQL actually use this memory?
Actually, SQL Server is very hungry for memory. If you see that SQL Server use a lot of memory, you should not be scared that much, okay? But if you see that SQL Server using a lot of CPU, average more than 30% of the CPU resources, then you need to be very worried about it and you need to investigate. But in terms of the memory usage, that's fine. If let's say you let the SQL Server use up most of the memory, that's fine, because SQL Server is loading all the data into the memory for the select statement or for example, the CRUD statement, create, retrieve, update, and delete statements. So whatever data that we are modifying or we are selecting, firstly comes to the memory, then from memory sent to the client side. So if we have a lot of memory, we are actually keeping a lot of data inside the memory, and this one will increase the performance of the queries.
Okay. Interesting. Does SQL Server release the memory to folks who are non-SQL folks? It would be helpful to understand. Does SQL Server ever release the memory to OS?
Yeah, actually SQL Server has one process called lazy writer. Lazy writer is a process which managing the buffer pool. Okay, so what it does, it comes and scan all entire buffer pool, but usually it has few threshold. It will come and scan when the SQL Server instance is under memory pressure, okay, or the OS is under memory pressure. Actually, SQL Server instance and the Windows Server, they are collaborating. Okay. So when the server is under memory pressure, external memory pressure means the physical memory is not enough, and the Windows needs more memory. It will call the SQL Server lazy writer process to come out and release the unused buffer pools. For example, you just select the data from last 24 hours and you select it one time, and SQL Server keep it inside the buffer pool. And lazy writer will come out and we'll check that this data is just selected and it doesn't use anymore. It will release it. And those dirty data, it will be flushed into the disk and it will change to the clean data, and if necessary and if it's needed, it will drop from the buffer pool as well.
Okay, interesting,
Yeah.
interesting. So if I if just to come back again to capacity planning, so is there any guideline? I understand how important it is to set the right limit to the memory. So is there any guideline that you have to in setting the maximum memory?
Actually, the maximum memory, we need to come out with a calculation,
Okay,
the formula based on the Windows version and the edition as well,
okay,
and the SQL Server version and the edition as well.
okay,
Then we have fixed formula. Then the DBAs, they need to do calculation. Then they will come out with the maximum memory setting. But always remember that maximum memory setting is only for buffer pool.
okay,
So other spaces like SQL MGR, the column store cache, or for example the plan cache, and other stuff like the threads, because in the SQL Server we have the worker and the threads as well, and each worker depends to the architecture consuming the memory as well. So we need to come out with this calculation. We need to find out each section how much memory they are using. Then we minus the total physical memory.
okay.
Then after that we will come out with the maximum memory size, because maximum memory size is for the buffer pool.
Okay, okay. Is there anywhere do you have that formula for our viewers to check it out? Do you have a link or
Yeah,
something?
actually in one of my blog posts I already come out with the formulas, which
Okay.
if possible I can share with your
Sure.
viewers.
Absolutely.
Yeah.
Absolutely. Sure. So that's interesting. So basically you need to figure out what are the things that are actually getting used, and then
Exactly. leave
out the stuff for other components, and then allocate for the maximum for the buffer pool. Yeah.
Exactly. Otherwise, sometimes some people, some DBAs, they have this policy. They will set the minimum memory required. I
Okay.
have seen. I'm very honest with you. I have seen those big companies, instead of setting maximum memory usage, the memory configuration, they set minimum memory configuration, which it doesn't make sense. It's like it's using 100% of the memory. So that's why we need to set the maximum instead of
Yeah.
minimum.
Yeah. One thing probably some people can get confused is minimum regarding the what actually minimum memory implies. Probably you can clarify to our viewers. Yeah.
Minimum memory is just the minimum usage, which is 16 MB. So when we set the minimum and the maximum memory usage in SQL Server instance, we are actually saying the SQL Server instance, you have this boundary. Minimum, for example, 1 gigabyte and maximum 16 gigabyte.
Oh,
So when it starts the engine, it will allocate 1 gigabyte straight away.
okay.
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 And it will reserve up to, let's say, 12 gigabyte. Okay.
Okay. Okay. Fine. Fine. Interesting. So recently we had this concept of AWE and PAE, and
Yeah.
some people are confused. Okay, I am using 64-bit. I don't need AWE. So there is quite a bit of misconception in and around this concept. Can you clarify what AWE is, and which versions does it apply? Yeah.
Actually, these features like AWE and PAE is for those old version of Windows Server and the SQL Server, and when those 32-bit processors was around. But nowadays, you know that new servers, all of them 64-bit, and we don't need to enable these two features. And even though we enable in the 32-bit version and the processor, we need to be very careful. Okay, for example, you enable AWE and /3G.
Okay.
Okay, actually it has conflict. Windows, it will come out with the memory page. Memory page is another 4 KB page by default, which is allocating and mapping to the memory blocks. Okay, when we enable the 3G, okay, /3G, it will change it to 8 KB.
Okay.
And when we enable the AWE, it needs to use the 4 KB. So it has conflict and the performance will reduce.
Okay.
That's why we don't really suggest people that they straight away enable these two features without studying their server behavior.
Okay, fine. Just to, that prompts me a question from me, like, in case if we are on those old servers, let's say for 2008 R2 and a 32-bit machine, so does it make sense to enable AWE on that machine? Let's say someone, I know it's pretty old, but does it make sense to just enable AWE and not 3GP?
Yes, it does. It does. Okay. Because SQL Server itself, it will go and use the unused and unallocated memory by itself.
Okay.
It works. But if it's better that they upgrade to 64-bit and the new editions and the versions.
Absolutely. So coming back to exactly capacity planning. So is there any method? What is your suggestion for some DBA who is actually starting up to, perform capacity? How does he plan how much of memory he needs to prepare for his server and his project?
Okay. As I mentioned, let me share my screen with you.
Yeah.
As here in this blog post that I wrote, this one only, can you see my
Yeah, I can see.
Okay.
Thank you.
Okay, this one is actually the formula that memory capacity planning. I came out with this formula, not I, actually Microsoft people, they came out with this formula. So I got from Microsoft development team.
Okay.
So it's if let's say your Windows server, but only 2008 and later versions until 2016, if it's 64-bit, if it's 32-bit architecture with GUI, this is the formula.
Okay.
If let's say our physical memory is less than equal 16 GB, then we reserve 10% for the Windows itself.
Okay.
And so on. Either is core, is it 64-bit GUI or core, and even for Ethereum architecture 64-bit as well. It's different. Okay. Then we usually will reserve another 1 GB or 1.2 GB for the DLLs.
Okay.
The SQL Server Engine DLLs. We will reserve another memory space for MTL.
Okay.
For example, you take the backup, the threads, all of it goes to the MTL. It doesn't go to the buffer pool. Okay. So MTL, we need to calculate based on the schedulers, how many CPU cores that SQL Server using, times by 255, times by the memory usage that is based on the architecture. So if let's say we are using 64-bit, so it will be, for example, 4 cores times 255 times 2 MB. Then we will come out with the MTL. Then the other one is the plan cache from 2005 service pack and 2005 service pack 2 and later up to 2016. This is the formula. If let's say, as I mentioned, for example, our server is using the 32 GB memory and it's 64-bit and 2016 is installed in the server. Just imagine 75%, if let's say it's between 4 GB and less than 64 GB, 75%.
Okay.
From 4 GB and 10% from the extra. So 3 GB and the 10%, it will be 48. 60 and 9 GB.
9 GB.
So 9 GB only allocated for plan cache.
Okay.
And if the plan cache is not enough, it doesn't have enough memory, what will happen? We will face the stolen pages. Okay. So SQL Server will steal the pages from buffer pool and make it multi-page instead of single page. Okay. So that one will reduce the performance significantly. And the buffer pool at the end for the OLTP system, what we usually say, either you deduct all these calculated values and you deduct it from the total physical memory, or you just come out with the OLTP. If let's say your database is OLTP, 1/6 of active portion of the database, or 1/10 of the entire database. And for OLAP, 20 to 30% of the total database size is the memory of the buffer pool.
I think there is a change in between OLTP and OLAP. Like, what is the reason for the change in the formula?
Because the OLAP, as you know, is the data warehouses and mostly is the select basis.
Okay.
So we need to have more buffer pool to keep all the data. Otherwise, we will have a lot of disk I/O. But OLTP stuff is just inserting the data. It's very random. We don't face any huge select statements that retrieving a lot of records. But be honest with you, I have seen that OLAP also the OLTP systems also selecting a lot of data. Yeah. So it's not surprised. But this is the formula that we need to follow.
The guideline that we can.
Yes.
Yes. Nice. Pretty comprehensive, actually, covering lots and lots of several aspects of the memory. And just another question: does it the thing explained? It holds good for all versions till 2016, right?
Yeah, still works. All versions from 2005 until 2016.
Okay. So one of the things which got introduced regarding memory was this buffer pool extension in 2014. Yeah. So how do you think it helps in capacity planning and memory usage?
Okay, actually it's good for those companies that they are having old hardwares, but they are using the SQL 2014 and they cannot add on the memory, the main memory.
Okay.
But if you look at it, at the end, because I did analysis, at the end, even we use the buffer pool extension, the recommended is the SSD drives. And SSD drives, they say, is faster than normal disk, okay? But still, at the end, it's I/O, it's the disk I/O, and it's not nanosecond, it's millisecond. Okay. And at the end, still from reading the SSD drive, we don't really, the performance doesn't increase much.
Okay.
So what I suggest to people that we better put it as a very, very last resort. If we can add on the main memory, that's great, because main memory is the nanosecond and it's very fast. If let's say they want to use the buffer pool extension, they can use it, but if possible, it's better that they use the RAM disk.
Okay.
Like those PCI RAM disks, those fast storage, or NVDIMM.
Okay.
If they're going to use that one, also it works well.
Okay.
So the last one is only the SSD drive.
Okay. Sorry, I'm not a hardware expert, so let me ask this question. The disk that you're mentioning, do you mean to say instead of using the buffer pool extension, it's better to just use these faster drives which actually give you decent performance, if I get it correctly?
No. Okay. I didn't mention the RAIDs or other stuff. If possible, we go for main memory, the memory module, the RAM. The second option, if you want to use the buffer pool extension, is better you go and use the RAM disk.
Okay, RAM disk instead of...
Yeah, as another hardware that is very fast.
Instead of SSDs. Okay.
Yeah. Then the third one is SSDs.
Okay, thanks for the clarity.
Yeah.
Okay, that's great. Okay, second thing that, another thing that got introduced in 2014 related to memory is obviously the in-memory OLTP. So how does one actually size in-memory OLTP? Yeah, how does one size if they use in-memory? It's $1 million question, I know that, but I'd love to have your views on it.
Yeah, actually in-memory OLTP is very good feature in 2014. In 2016, enhanced a lot in terms of performance, manageability, administration, but there is some problem, which is not the SQL Server problem, it's the DBA's problem. They don't come out with a calculation how much that in-memory OLTP databases or those memory optimized tables needed the memory space. So they always they don't provide sufficient memory for in-memory tables. Then they face the performance drop instead of increasing. it drops significantly.
Yeah, that was
And
one of my questions as well. Like, there are people complaining, saying that after I moved to in-memory, my has dipped. So,
exactly. So this one also has another formula which need to go through it. I'm going to share my screen and I will show you the slide that I already put the formula there. Okay, do you see my slide here?
yeah, just come.
Okay, this one is the in-memory estimation. I'm still saying it's just estimation,
Okay.
but some people, they don't even estimate it.
Okay.
They just create it and they think it needs to work well. So just imagine we are having one in-memory OLTP table.
Okay.
We have 9 columns. The first 5 columns are indexed
Okay.
and integer value, as you see. The first one is primary key non-clustered. The
Okay.
second one is the hash index.
Okay.
Third one also hash index. Fourth one hash index, and the fifth column having non-clustered index. Column 6, 7, 8, and 9 is just the normal column, and width optimized, memory optimized, on.
Okay.
We don't consider the primary key. We don't calculate the primary key non-clustered. So
Okay.
we only calculate column index 1, 2, 3, 4.
Okay.
Okay, for in-memory tables, we need to calculate 4 different areas because in-memory OLTP will use this much of memory.
Okay.
First, we need to calculate memory for the table.
Okay.
The table means the raw data, not just indexes,
Okay.
only raw data. So what we need to do, timestamp plus index pointers plus raw data, which is timestamp is 24, begin and end transaction timestamp,
Okay.
plus 4 8s, because we are having 4 indexes. As I mentioned, the primary key non-clustered, we need to ignore it. So 4 8s plus, as you see, the 5 4 bytes, which is the integers,
Integer
and
column.
50, yes, 50, 50, 30, and 50. Don't forget, I mentioned not null. I not just add another 2 bytes in a row.
Okay.
This one is very simple table for calculation. So, as you see, for example, 5 million records, as I put here, bucket count 5 million, I need 1.28 GB only for raw data.
Yeah.
The other one is the hash indexes. I need to round up the bucket because 5 million is not valid, the number. So we need to round it up to power by some number which is
nearest.
more than 5 million but close to 5 million.
Yep.
So it will be 2 powered by 23 times 8, which is the index pointer. So for hash indexes is 64 MB times 392. Okay, it's not that huge. The other one is for non-clustered index, which is index pointer plus some of the key columns, but currently we are only having one key column, which is 4 bytes. So 8 plus 4 times 5 million, 57 megabytes for one non-clustered index. We don't consider the primary key because this one is inside the table data.
Table data.
Yeah.
Okay.
The most important part we need to calculate is the memory for row versioning.
Yep.
As you know, in-memory table, in-memory OLTP and in-memory tables, they are using row versioning technique.
Yep.
So for every operation, it will copy the record and it will do the changes on the recent copy. So what is the formula is the longest transaction duration in second. Okay. For example, our longest transaction duration is 1 second. And within a 1 second, how many rows will be updated and deleted in a second? We just mentioned 10.
Okay.
And we need to times it by the row size. So in our example, 1 second times 10 times 256, which we calculated here, it becomes 2560 bytes, which is 2.5 KB, around that. We just imagine in this table, 30% of our record is keep on changing.
Okay.
So we need to times it by 5 million, 3.66 GB is the raw versioning. So we need to come out with the sum of these calculated values, 3.66, 57 MB, 192 MB, and 1.28 GB, just allocating for in-memory table.
For a 1.2 GB table itself,
Yes,
we need to allocate this much.
Exactly.
And yeah, we also take into account how much of our table is going to be edited. We took an assumption of 30% in this particular case.
Yes, correct.
Okay.
I highly suggest my clients that if they want to use in-memory OLTP, it really works for those tables that they are insert only.
Okay.
If you keep on inserting record in memory OLTP, you can ignore this row versioning section. But if your table is keep on updating and deleting the records in memory OLTP, then you need to consider this row versioning.
Okay. So what happens when somebody actually sizes it lesser? So
when it's size lesser, then the performance decrease.
Okay.
Because all of it is in the memory, what will happen? SQL Server will ask the Windows to do the paging, system page.
Okay.
So actually all our in-memory data, it will page into the disk, and if it's needed, it will read from the disk. It's the swap in, swap out.
Okay. For the in-memory tables as well, is that the behavior, or?
Sorry?
For the in-memory tables as well, is that the...
Same. We need to have it. It will have it like that if the memory is not enough.
Okay.
Yeah.
Okay. Fine. So in SQL Server 2016, there were quite a few changes done to the standard edition and the rest of the editions, and also some changes related to the memory usage. How do you see those in terms of memory with Service Pack 1, 2016 Service Pack 1? How do you see the changes?
Actually, when the SP1 released, I was in shock. Okay, because a lot of features that available for even in Express edition, but in the standard edition they even enable in-memory OLTP and column store indexes, but it's very limited. And in terms of memory usage, column store, as I mentioned, column store is not in the buffer pool. Okay, it's actually out of buffer pool. So whatever, if let's say you are using the column store index in your database system, you still need to calculate how much memory used, then deduct it from the total physical memory to come out with the buffer pool. We skip that one. Okay. Column store index is using the column store cache.
Okay.
Which is in standard edition is maximum 32 GB. In enterprise edition, if I don't mistaken, is maximum the OS size. Means the OS, how much OS can support the memory, then it will support it as well. And this column store is per database. It's not per instance. Okay? So the 32 GB for column store cache is per DB, not per instance. And in-memory OLTP same is the 32 GB, if I don't mistaken, and it's per DB as well. Okay, but in the if I don't mistaken, in the enterprise edition is up to 2 terabytes.
Yeah. In fact, they are even considering to remove the limit as it's scaling up.
Yeah.
Okay. Interesting. So just to summarize, like, what happens if somebody actually configures memory incorrectly? What are the side effects, or what kind of signs does one see?
Okay, a lot of things can happen. Based on my experience, first thing that they will face is the slow performance, which is caused by either internal memory pressure within planned cache, stolen pages, not enough buffer pool to keep all the data. So these things that it cause the performance issues. And when you configure the memory usage, the maximum memory configuration, then you will see the instance changes.
Okay, fine. So what are the warning signs? Like, how does someone monitor any performance counters that you would recommend for people to monitor to realize that they have actually did a misconfiguration?
Basically, they need to use the DMVs. to check the planned cache internal memory pressure. So they need to come out with the number of entities in each bucket. And if let's say the bucket is almost full, means that we are facing the internal memory pressure. And also they need to check the buffer pool descriptor in the DMVs, which how much data, how much buffer pool is used by each DB. If it's a lot, then they need to check. And another thing that is causing the performance and high memory usage is unnecessary non-clustered indexes. I have seen in the databases that the pure data, the raw data is, for example, is 200 GB, but because of unused non-clustered indexes and not designed properly, they increase the database size to few terabytes. They are applicating into the indexes, and those indexes also they need to be loaded into the buffer pool as well. So it's consuming a lot of memory.
Okay, interesting. So even the unused indexes needs to be monitored to find
exactly. Yes. Yeah. Actually, unused indexes also can cause the I/O overhead as well.
Okay, fine. So actually, I didn't realize how much of time has passed. Actually, we have spoken for more than 30 minutes. So that's wonderful. Yeah. So we are coming down to the end of the interview. Thanks a lot, Hamid, for all your time.
You're welcome, Nagaraj.
Thanks a lot again. And it was very, very useful for me as well. Yeah, thanks a lot.
You're welcome.